This is the third and final page of today's notes. We're going to start by identifying all the different parts of a term. Keep in mind this is considered a term because there is no addition or subtraction. Every time you have addition or subtraction, that starts a new term. There is multiplication in here, there is an exponent in here, but there's no addition or subtraction, so this would all be considered one term. And there's three distinct parts to this term. This -3 is one part, the x is a second distinct part, and the 5 is a third distinct part. That -3, or whatever number is coming in first in our term, is called a coefficient, and it's F-F-I-C-I-E-N-T. This is a coefficient. It's the number in front of our x in this case, which is our variable. Anytime we have a number in front of a variable, that's saying to multiply, but we also call that number a coefficient. And then our third piece here is our exponent. In this case, it's 5. Those are three really important parts to terms. Now, we define that because what we're talking about now is combining like terms. And there's a very specific definition of what like terms are. They must have the 2 terms or 3 terms or 4 terms, however many terms there are, the exact same variable and the exact same exponent. When we're combining those like terms, we are going to add or subtract, depending on the signs, the coefficients of those like terms, but we will not ever change variables or exponents. So to be a like term, we're looking at the variables and exponents. Once we identify the terms that are like terms, we only are going to add or subtract their coefficients. We'll never add or subtract exponents in those cases. Let's look at some examples. In number 1, we have 2 terms. We have a term of 4x, 4 is my coefficient, and then we have a second term, because this is separated by subtraction, of x. Both terms have an x and an exponent of 1. That's an exponent of 1 even though it doesn't appear. Therefore, my like term is x. I can go ahead and just write that down. I know that'll be in my answer. And my coefficients here are 4, and even though it's not here, there really is an invisible 1 there. So I'm going to take 4 minus 1, I get 3. That becomes the coefficient of my answer. I get 3x. In number 2, the process is the same, but I have 1, 2, 3 terms. Only 2 of them are like terms, 5x squared and 3x squared. I sometimes will do this and underline the terms that I know are like terms. I know they're like terms because they both have x. Both of the x's have an exponent of 2. So again, in my answer, I know I'm going to pull that down, my x to the 2nd power. I'm not going to make that x to the 4th power. I don't combine exponents. I only combine my coefficients. In this case, my coefficients are a 5 and then a plus 3. 5 plus 3 is 8. That becomes my coefficient of x squared. So I've used this and I've used this. I haven't used this yet. All I need to do is bring that down. I can't get rid of it, but I can't combine it with my 8 because it's not a like term. It doesn't have an x squared. go ahead and press pause, try numbers 3 and 4, and then you can stop. But try to do number 3 and number 4, and after you're finished, unpause it and check your answers. So our final answers should be negative 4x squared plus 10x on number 3, and negative 9x for number 4. Quick explanations as to why. Later on in the school year, we'll talk about why my x squared term needs to go first. But if you had 10x minus 4x squared, I would have accepted that today. Later on in the semester, that would not be accepted as a final answer because it's not in what we call standard form, which means my exponent that is biggest, that term needs to be listed first. So for now, if this is what you had, I'd give you credit. But if you had 4x squared minus 10x, now it's not correct because you're saying your 10 is negative when it should be positive, that your 4 is positive when it should be negative. And in this case, I have a negative 4 and a minus 5 in front of my x. The x stays the same. Negative 4 minus 5 is negative 9. The last two problems today are actually a combination. I cannot add 1 and my minus 2x, even though those are in parentheses and the order of operations says I need to simplify those first. They're not like terms. So because of that, I must first get rid of my parentheses by using the distributive property. The only thing I am distributing here is my negative 4. Again, I'll erase that and talk real quick. I cannot, I repeat, cannot take 1 minus 4 because then I'd be doing something other than my parentheses first. You can't add or subtract before you eliminate your parentheses. So I have to work on getting rid of my parentheses. That means multiply or distribute my negative 4. This 1 will just be brought straight down. Negative 4 times 1 is minus 4. And negative 4 times minus 2x, negative 4 times minus 2 is positive 8, and then I have an x. Now I can find my like terms. I got rid of my parentheses by distributing. I have like terms, a constant term of 1, a constant term of 4. Those are considered like terms because they have no variable, no exponent. That's the same exact variable, same exact exponent. Same thing. 1 minus 4 is negative 3. Bring down my plus 8x. I have my final answer. Number 6 is similar, and this is one that you want to pay close attention to. It's one that lots of students get wrong. I am not distributing a 2 or a negative 2 here. Directly in front of these parentheses is only that minus sign. The negative 2 I bring down just like I brought the 1 down in number 5. And I distribute my minus sign. It's basically saying take that x and make it negative, minus x. It's also saying take that positive 5 and change the sign, make it opposite, minus 5. Now, again, I have two constant terms that are like terms, a negative 2 and a negative 5. I bring this negative down with my x, and then I take my negative 2 minus 5. If you need to do these things, or negative 4 minus 5, and your calculator, by all means, please use your calculator. We should get that this is negative 7, so I have negative x minus 7, final answer, and I'm done. If everything has made sense, you're now ready to move on to your homework worksheet. If you've struggled on any of this, please go back and re-watch the videos to help you get caught up.